So we're going to look at solving quadratic equations. We've done a lot of solving quadratic equations. We've done it by factorising, and we've got two examples here, and we're just going to look at again the method that we've used in the past. So what we've got is we've got two quadratic equations. They're both made equal to 0. You can see example 2 is not initially given in the format of being equal to 0. It's been rearranged, and you know that the rule is that you have to rearrange a quadratic so that it's equal to 0 in order to solve it. So example number 1 is a nice straightforward example. We're going to put this into two brackets and make it equal to 0. Now, as I'm working through this video, I don't want you to make any notes. I just want you to listen to what I'm doing, and then at the end, on the last sheet, I've got some notes for you to put into your book. If there's an example, then you can work it through with me, but for the majority of the time, I just want you to look and to listen. So we're going to put the example number 1 into two brackets. Nice straightforward. We've got x plus 1 and x plus 2. 2 and 1 multiply to make 2, they add to make 3, and they're the correct brackets. Now we know from the past that we've then said that because we've got two brackets that multiply together to make 0, then one bracket or the other bracket must be 0. So we know that x plus 1 must be 0, or x plus 2 must be 0. And that gives us the two answers, that x is negative 1 or x is negative 2. Example number 2 is not quite so straightforward because we've got 4x squared rather than just a single x squared. You've got various different methods of putting this into two brackets. Split in the middle term is one of the ones that my group has already done, and you could use whichever method you wanted to get into the two brackets. I'm going to go straight to the two brackets rather than go back over split in the middle term, and you would end up with a bracket which is 2x plus 1 and a second bracket which is 2x take away 3, and those are your two brackets. Again, you know that 2x plus 1 must be 0, or that 2x take away 3 must be 0. I'm going to solve these equations. So 2x is negative 1, and so x is negative 1 divided by 2, which is negative 0.5. Or we have that 2x equals 3, and so x equals 1.5. So these two equations we have solved using the method that you should be very familiar with, and we've used the method of factorising the left-hand side. So we've got two other examples here. We've got example 3, and I've highlighted the negative 5 and the negative 7. We're looking for two numbers that would multiply to make negative 5 and add to make negative 7. The only two numbers that multiply to make negative 5 are 5 and negative 1, or negative 5 and 1, and they don't work. So this isn't an example where we can factorise. But there are still values of x that could make this true. The difference is that they're not integers and they're not simple fractions. So the method that we've already used can't be utilised here. Example 4 on the right-hand side is quite a complicated one, and it may be one that would factorise, although this one possibly doesn't. But you've got 7x squared, and so it becomes quite complicated. You may actually want to use a different method than trying to find some kind of factors for these equations. So what we can use is we can use something that is called the quadratic formula, and that's what we're going to be looking at in the next few examples. So to start with, we're going to go back to example 1 because we've already solved this, and on the left-hand side of the page we've got the solutions that we came up with right at the beginning. We know that x is negative 1 or x is negative 2. So we're going to apply the quadratic formula, and we're going to see if we get the same answers. So on the right-hand side we're going to use the quadratic formula. We've got x squared plus 3x plus 2 equals 0, and we're going to compare it to ax squared plus bx plus c. So your value of a is how many x squareds you have. And you can see very clearly that we have 1x squared. Your value of b is how many x's you have. And you can see that we have 3x, and so b is 3. Your value of c is the number that is on its own without any x's, and so that is 2. So we have a value of a value of b, and a value of c. These are then put into the quadratic formula, and I've got the quadratic formula written out here. It gives an answer for x, or two answers for x, depending on how many there are, which are given to you by using these values a, b, and c. The quadratic formula is that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula that you're going to have to learn. You don't need to learn it at the moment, but you will need to know it. It's not given to you in an exam. We will practice these formulae, so for the minute I don't want you to worry too much about learning it, but the more you use it, the more you will get used to it and start to remember what it is. So what we're going to do here is we're going to substitute in our different values. So the value of a is 1. You can see that where a is in our formula is here, and we've replaced 1 and 1. The value of b is in the formula minus b at the beginning, b squared in the middle. So minus 3 at the beginning and b squared within the square root sign. And then the value of c is at the end here. And so we substitute it in. We get negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 2, all divided by 2 times 1. And on the second line, I've actually put this using the numbers. So I've still got negative 3. 3 squared becomes 9, and 4 times 1 times 2 becomes 8, and 2 times 1 on the denominator becomes 2. So my quadratic formula has simplified down to negative 3 plus or minus the square root of 9 take away 8, and that's all over 2. 9 take away 8 is clearly 1, so we then end up with this square root sign being simplified down to 1, the square root of 1. And at the bottom, we can end up then with 2 clear solutions. Now, why are there 2 solutions? There are 2 solutions because our formula includes plus or minus. So one solution you can see is given by plus, and one solution is given by minus. The first one is negative 3 plus 1 all over 2. Now, negative 3 plus 1 is negative 2. Divide that by 2, and you get an answer of negative 1. And negative 3 take away 1 is negative 4. Divide that by 2, and you get an answer of negative 2. And these are the same 2 solutions that we had from our factorization. So let's do the same with example 2. Again, on the left-hand side of the page, I've got our solution that we did before. We factorized it, and we ended up with 2 answers for x, one which was negative 0.5 and one which is 1.5. So on the right-hand side, we're going to use our quadratic formula. The values of a, b, and c, again, we're going to compare. The value of a is 4. The value of b, this time, the value of b comes out as a negative, so it is negative 4. And the value of c is also negative. The value of c is negative 3. So our quadratic formula, x is minus b plus or minus the square root of b squared minus 4ac all over 2a. This time we're going to work it through. So I'd like you to pause the video and have a think about, and you can just do this in your books, writing in the values of A, B and C into this quadratic formula. So you can see that I've started this off. Because B is negative, I've put -4 into brackets, and C is negative, I've put that in brackets as well, just to be very, very careful. So minus B at the beginning of our formula becomes -4. Take away -4, which becomes a +4. And then we've got -4 squared, which is 16, plus, because we've got two negatives, so a negative and a negative becomes a positive, 4 fours are 16, times 3 is 48. So we end up with our quadratic formula becoming 4 plus or minus the square root of 16 plus 48 all over 8. So x equals 4 plus or minus the square root. 16 plus 48 is 64 all over 8. Now the square root of 64 is 8. So we end up with two solutions, that x equals 4 plus 8 all over 8, or x equals 4 minus 8 all over 8. If x is 4 plus 8 is 12, divide it by 8, that's 1.5. Or x is 4, take away 8, which is -4, divided by 8, so x equals -0.5. And again, we've got the same solutions as we did when we were factorising. So let's move on to example 3, which was one of the ones that we couldn't factorise, and so we're not expecting our answers to be an integer or to be a nice simple fraction. So I'd like you to work this one along with me. We put a title of Quadratic Formula into your books and write down the example x squared minus 7x minus 5 equals 0. I'd like you to then write down your values of A, B and C and to have a go at putting them into your quadratic formula. You don't have to work it through to the answer. You can if you want to. Otherwise, just try putting it into your quadratic formula and go as far as you can, and then come back to this video and we'll work it through together. So you can see from my solution here that A is 1, B is -7, C is -5. I've substituted it into the formula, being very, very careful with my negatives, and I've ended up with x equals 7 plus root 69 all over 2, or x equals 7 minus root 69 all over 2. Now, 69 is not a square number, so this is clearly not a nice answer. So you can square root 69 on your calculator and work out your values. 7 plus the square root of 69 over 2 comes out as 7.653319, and 7 minus root 69 over 2 comes out as -0.6533119. And I've given my answers here rounded to 2 decimal places. So I'd like you to stop the video and to write this solution down into your books. Now we're going to look at example number 4. This time we have more than 1x squared, so A is going to not be 1. We have a positive value of B, but we have a negative value of C. So again, I'd like you to pause this video. I'd like you to write this example down into your books, and I'd like you to have a go at substituting it into the quadratic formula. So here is my solution, and I'd like you to just copy that down and follow it through if you haven't already done that one, and check that you get the correct answer. So we've done several examples with using the quadratic formula. You can see how useful it is to solve quadratic equations. I'd now like you to write these notes down into your book, and so that you have very clearly written down how to use this formula to solve quadratic equations.